everyone. In our previous lessons, we learned about the basic knowledge of tractors and the structural components and fundamental principles of engines. What kinds of faults can occur while using a tractor? How do we analyze these faults? What are the methods and principles for analyzing them? Let's now learn about the principles and methods for tractor fault analysis. This lesson will focus on three aspects. 1. The external manifestations and causes of tractor faults. 2. The principles of fault analysis. 3. The methods of fault analysis. 1. External manifestations of tractor faults. When a tractor develops a fault and cannot operate normally, it exhibits some abnormal phenomena. For example, if the diesel engine cannot be rotated by hand when operating the decompression handle, it indicates it cannot decompress. If the steering fails or the tractor veers during driving, or if the diesel engine makes a heavy, hoarse sound accompanied by shaking, these are often signs of serious faults. When a tractor is leaking water, fuel, lubricating oil, or electricity during operation, it also indicates that the tractor has a fault and should not continue to be used. Abnormal consumption of lubricating oil, fuel, or cooling water in the tractor also suggests that the tractor has a fault and cannot continue to be used. 2. What are the causes of tractor faults? There are two causes of tractor faults. First, normal reasons. Due to the movement of parts, material fatigue, and changes in temperature and humidity, parts can experience normal wear and leakage. Additionally, seals made of materials like rubber can gradually lose elasticity and impact performance due to adverse factors such as oil corrosion, oxidation, and temperature catalysis. Second, abnormal reasons. These include faults caused by the operator's unfamiliarity with the performance of the tractor's working devices, improper operation, overloading, untimely maintenance, and lack of diligent upkeep. Next, we will learn about the principles of fault analysis. When a tractor malfunctions, the signs are diverse and the causes complex. The occurrence of any fault is due to its essential reasons. In conducting fault analysis, follow these principles. 1. Do not dismantle or unload haphazardly. Diagnosing faults requires diligent thinking and good summarization, employing both divergent and convergent thinking methods, and proceeding with disassembly only after careful analysis. Resorting to blind dismantling out of wishful thinking upon encountering a fault is extremely detrimental and must be overcome. 2. Use phenomena as a guide to understanding. Look beyond the appearance to see the essence. Adopt a perspective of development and change when analyzing issues, making specific analyses in specific situations. 3. Consider the structure and principles together. Analyze organically by segmenting systems based on the function, principle, structural characteristics of each component and their interrelationships, making inferences and judgments accordingly. 4. Follow the principles of progressing from simplicity to complexity, from the superficial to the fundamental, tackling easier issues before more challenging ones, segmenting by system, and methodically following leads. 5. Be good at summarizing and accumulating experience. Only through repeated practice and long-term production, gradual realization, continuous summarization, and mastering patterns can one be well-informed and make accurate judgments when analyzing faults. 3 methods of tractor fault analysis. 1. Isolation method. This involves isolating or disconnecting the component where the fault is most suspected. If the fault symptoms are immediately eliminated, it indicates that the fault originated from this component. If the fault symptoms persist, it suggests that the fault lies elsewhere. Common methods include cylinder cutout diagnostics to identify faulty cylinders, such as the method for diagnosing black smoke or abnormal sounds. 2. Trial and error method. Within the range of potential faults, certain parts are tentatively removed or adjusted to determine if they are functioning normally, known as the trial and error method. For example, if it is suspected that excessive valve clearance has altered the normal valve timing, causing insufficient engine intake and a decline in diesel engine power, the fault can be troubleshot by first inspecting and adjusting the valve clearance. 3. Comparison method. This method involves swapping a suspect component with one that is known to be working properly to determine if there is a fault based on changes in symptoms, referred to as the comparison method. For instance, if a particular injector is suspected of malfunctioning, it can be replaced with a functioning injector for comparison to ascertain whether the fault lies with the injector. 4. Instrumentation method. Utilizing instruments and gauges allows for an accurate understanding of the internal condition of the tractor without dismantling or with minimal dismantling, known as the instrumentation method. Common tools include non-destructive testing instruments, cylinder pressure gauges, multimeters, etc. In conclusion, tractor faults are complex and varied. In this lesson, we have learned how to analyze faults and which principles and methods to follow to make reasonable and accurate diagnoses and remediation for subsequent lessons on engine, chassis, and electrical faults. Lastly, please consider, what faults can occur in a tractor? Please list one example and provide a diagnostic method. This concludes our lesson for today. Thank you, everyone.